Good afternoon, ladies and gentlemen of Algebra 2 Honors. Good to have everybody here today. And this is the last day of school we have here today during Holy Week. And we will be off tomorrow in recognition of Good Friday. So anyway, here we are. The first two problems are these where you solve rational equations by graphing using a table of values. And so what I want to do today is just kind of quickly go over this one here, kind of show the process. We demonstrated briefly yesterday what it was when you were taking notes. Remember that a little bit? So this one right here, how are we going to go ahead and set this one up to solve by graphing? So solve one side of the equation for 0. How do we do that?
You add both sides by 3. Add 3 to both sides.
So we'll add 3 to both sides. So we have is x over x plus 4 plus 3 is equal to 0. And now we can start plugging in values here. So first of all, if we plug in -8 for x, we get -8 over -8 plus 4 plus 3. And so what we're going to get here is you get -8 over -4, which simplifies to 2. Is that right? And 2 plus 3 is going to be 5. So 5 goes here. So you get the point -8 comma 5. And I want to show you something that is just sort of a little hack, if you want to call it a hack, on going ahead and using your calculators to figure this out. Like if I go, let's say I want to put -3.5 in place here, because that might be a little more complicated number. Well, I go here and put in -3.5 storage x. And so now I have 3.5, so whenever I put x down again, I get -3.5. So that means I can go here and put the expression here, x over x plus 4 plus 3, right? And then plus, oops, x, I got it wrong here. X plus 4, I don't know what happened here. Plus 4, and then out here put plus 3. And so I get -4 as an output. So -4 is going to be my output here. So the point here is -3.5 comma 4. Does everybody see how I did that with the substitution in the calculator? Okay, you put the number you want to represent here, which I'm going to do it one more time here in case you didn't see it. I'm going to put well, for 0, you're just going to have 3. You know that, because that's going to be 0 plus 3, so that's going to be 0, 3. And then if you take, say, -2, so -2 storage x, and then we just can type it in like this. We can go like x over x plus 4, and then plus 3. So we get 2 as an output. So 2 is our output value here. So we get the point -2 comma 2. And then we have all these other ones. I think this one's going to be 6, is it? So you get -6, 6. And this one here is going to be, is it 8? -5, 8, or is it -5, 7?
8.
8. So -5, 8. So we have here is all the points, and what is going to be our excluded value from this equation here? -4. And what do we call this thing at x equals -4? What is the name for that? We call this a what? Excluded value. Excluded value. We call it a vertical asymptote. okay? But it's interesting, I want to take, because Ben said excluded value, and Jay said vertical asymptote. They're both those answers were right, but Ben was answering that from an algebraic perspective, whereas Jay was answering it from a graphical perspective. And so the language you use will decide which one you use. Okay, so that's some good work, gentlemen. Appreciate you doing that. And then we graph these things. We got negative 8 comma 5 will go right here. Negative 6 goes here. And negative 5, 8 goes here. So you're going to have something that looks like this over on this side. And then down here, would you go to the right, we have negative 3.5, negative 4 will go right here, very close to that vertical asymptote. And then we have negative 2, 2, so negative 2, 2, and then we have 0, 3. So we have something that looks like this. So on this graph here, how are you going to identify the solution? Where do you find the solution to this? Where the graph does what? Where the graph does what? Well, it turns everywhere, right? Where the graph does what?
Rotational symmetry.
Okay, this does have rotational symmetry. I didn't ask a question about that, though. What is it? But he's right. This is a rotation. It's rotational symmetry about the center, because the center is going to be about right here, isn't it? In fact, it probably is there. Okay, but where do we find the solution to this equation on this graph?
Remember something yesterday about the x.
What do you say?
Where it touches the x line?
Where it touches the x line, where it touches the, or the x-intercept. So at the x-intercept of this, which is what? X equals? X equals negative 3. And so let's go ahead and, but really it's going to be, Jay said the x-intercept, so the root x-intercept, or 0, is what you'd call it. In this case, it will be the solution also. So now in your calculator, I want to show by graphing where it is. And here's the equation graphed here. You see that? And then you can go to graph, and you can see where does the graph touch or cross the x-axis? At x equals negative 3. And then you can check also using your table view, and you can see your excluded value here of negative 4, and then our solution here at x equals negative 3. So what I want you to do is do problem 2, just sort of work on that. I'll call on somebody here in a few minutes for that. You know, choose somebody to help me. Name generator.
I could do that, because I have to plug in every single thing. I can. On the white, I just put Let me check if my single side is 0. No, we're just following my wrong. I did something better. Oh, I didn't put the minus there, but that's fine. 4 is negative 5.
Yeah.
7. What's negative 5? 10 is negative 2. I have a what was it? Did you do the other one? I got you.
You want to, I was doing. Yeah, I could, but no, not today.
So how do you know? I've got to exclude that.
I usually have nosebleeds a lot, but I have them all. Probably about.
How do you find this value? Well, I'm looking at the table and the error on it. That's what I got. Yeah.
Break out.
So excluded value is 5. Wait, let me see. Even though I kind of drew it all the way. That's right. Excluded value is 5.
Let me see your drawing.
I think it's 5. Because when you plug it in on the table, it says error on 5. That means that 5 is excluded value, but my drawing doesn't match up.
Or negative 5.
Touch it 5. Or negative 5.
So is it 6? Because it looks like it's touching
I
it.
don't know.
Looks like it's touching at 6.
5 is your excluded value. It can't be your excluded value. Because the point doesn't exist there.
Just hit math
The
2.
function doesn't exist.
Hit math on your calculator, and then hit 2, and then it'll change it to a pure.
I'll
Just check it. Right.
How do you get this
I
one?
don't know how to pick this one. I don't know what.
Teachers, will you please release the baseball boys at this time to the athletic hallway? Thank you.
Is that 6? Yeah. On my drawing, it looks like 6, but I don't know. On the table, it says error at 5.
10 equals 0. Your excluded value is what? You guys are doing
So it's 6. Oh, sorry. What is it
You
done?
guys are getting either graphed it or getting close to it. Okay, hint, your excluded value should be 5.
You mean, wait, he said 5, and he said it was wrong. Yeah. I think he means 6.
Oh, you did, yeah.
No,
Does he mean 6?
it's 5.
Yes or no? We said 5,
Because 2
and we
times
said
5
it
minus
was
10
wrong.
is 0.
No,
6.
I said the excluded value is 5.
Yeah. Excluded value is 5.
The vertical asymptote is 5.
Okay. We're gonna erase real quick.
Guess, go ahead. I'm going to choose somebody. You guys been doing some good work today.
5. is 6.
Okay, we have,
Okay, then why are my graphics across at 6?
Connor is gone. Okay, we got Benny Z.
For what? You're solving the problem.
Solve the
Benny.
problem, Benny Z.
Come on now.
All right, Benny Z.
Solving the problem.
That's Ben's nickname on the wheel of names. Benny Z. All right, let's have it.
Well, first you take the equation equal to 0,
Okay,
so you subtract 3 from both sides.
select 3, okay. So,
X over 2x minus 10 minus 2.
equals 0,
And then I plug in all the numbers.
okay.
So I got negative 3, negative 3.75,
3.75,
negative 5, 2.5, negative negative 1.25.
so that,
No.
well, negative 1.25,
Yeah, and then for number 10, it's negative
negative 3,
2.
negative 2, okay. So the next thing you did is you went and you plotted the points, is that right?
Right.
So what is your excluded value here?
5.
X equals 5, okay. So X equals 5 is our excluded value, which shows up graphically as a vertical asymptote. So we have 0, comma, negative 3 here. We have 3, comma, negative 3.75. We have 4, comma, negative 5. We have 5.5, comma, 2.5. We have 7, comma, negative 1.25. And we have 10, comma, negative 2. Now, what can you, by looking at what's in the table here, figure out, this is sort of a side question, Ben has taken us through this, but just anybody, what tells you from looking at this if your answer is going to be, your solution is going to be over here to the left of this vertical asymptote or to the right of the vertical asymptote? What tells you by looking at the table? But what tells you in the table that it's to the right?
The closest number to 0 are 2.5 and negative 1.25.
So the closest numbers to 0 are negative 1.25. Is that what you're saying?
Yes, and 2.5.
Okay, I'm looking for it. Okay, there's something that I don't know if we talked about in this class, but we would definitely talk about it in pre-calculus and calculus. It's called intermediate value theorem. And that an intermediate value theorem states that the function is continuous, and we know to the right of this vertical asymptote we have a continuous function. To get from, if you have a positive value that will change to a negative value, we know that the 0 has to be in there between them. And so we're going to articulate that better as time goes on. Go ahead, Ben, what's next? Did you graph these?
Yeah, I got it.
So you got like 0, negative 3, like this, 3, negative 3.75, so 3, negative 3.75, something like here, 3, negative 3.75. And then 4, negative 5, so something like this. 4. Yeah, 4, negative 5 will be right here. Yeah, so look like this. Something like this, right? Then over here on the other side, which we know where the answer is, so you get 5.5, 2.5, so it's going to be about here. And then we have 7, negative 1.25, so 7, negative 1.25 be about right here. And then 10, negative 2, so it'll be like this. So what is our solution here? Okay, solution, x equals 6. Okay, so that is it. Okay, thank you, man. Now, I'm going to want you to get people in the audience to solve 3 and 4. But before I have you do that, I'm going to backtrack to what we talked about yesterday when we talked about least common denominators. Okay. And it's this. Go over here to this. Find the least common denominator for each set of rational expressions. And I did these yesterday. My question is, why is a least common denominator helpful? We're going to find least common denominators here. But why do you want to find a least common denominator?
It makes it simpler, like in the long run. In the long run, it will like cancel out some stuff.
It'll cancel out some stuff. And what are you planning to cancel out by design?
The denominator.
You're planning to cancel out the denominator. So what you're trying to do is you're trying to put the least amount of stuff you multiply everything by to cancel out everything in the denominators of each of those things. For example, this one right here, what are going to be our, so the factors of this, 15x plus 60. If we factor this, what do we get? 15x plus 4. And then if we take the other denominator, x squared plus 9x plus 20, and factor this out, oh, that's 20. We factor this out, what do we get?
X plus 5, x plus 4.
X plus 5, x plus 4. And so what's going to be our least common denominator?
X plus 4.
Okay. More than that though. So x plus 4, what else? It's the least amount of stuff that's going to cancel out both of these denominators here when we multiply it by. So x plus 4, what else? 15. And one more thing.
X plus 5.
X plus 5. So we multiply all this by our least common denominator. We're going to have everything cleared out of the denominator. And then we have things cleared out of the denominator. Is that going to be an easier equation to solve?
Yeah.
Yes, it is. So that's really a strategy behind that. So I want you to go ahead and I'm going to call on somebody to do problem 3 here in problem 3 in, that's your turn. I'm doing the wrong thing. Get rid of that. No. There we go. Yeah, I'm going to call on somebody to give us a least common denominator for number 3. So work that out. I'm going to call on somebody. Okay, it's going to be everybody except. Okay, Julia, I've got your name. You came up on this one, Julia. Do you have it worked out?
You got it, Julia. This is for tomorrow.
Just a second, she says. And everybody else can go ahead, if you have a chance, you can also look at number 4. So 2x plus 16 factored is going to be
2 parentheses x plus 8.
2x plus 8, okay, 2 times 20x plus 8. And then right here we have
3 parentheses x minus 9.
x minus 9, okay. So what's going to be our least common denominator here?
X. I have no idea, to be honest.
Okay, you look for the things, the least common denominator. Can we do anything with these x minus 8, x minus 9, x plus 8? No. Because remember, we're going to have to multiply by this to clear out the denominator if we don't have these things. What about the numbers? What do you do with those numbers, 2 and 3? Multiplied, so 2 times 3, 6. So there is our least common denominator. So we multiply by that, we're going to clear out all of our denominators. Okay? And 4, from 4, we have, let's see, I'm going to be, it's going to be Kim. All right, Kim.
Okay. I factored out the first one and I got
Okay.
5 parentheses x minus 6.
So this is our first factored amount here. Okay, good.
And then the other one I got 7 parentheses x minus 6.
Okay, so what's going to be our least common denominator?
35 parentheses x minus 6.
And is that going to cancel out both of these denominators when we multiply this equation by that? Yeah, it is. So that's going to be it. And how solvable a problem it is when we do that, I think it's going to, I don't know. Okay, so we're going to leave it there today, and